Hi, my name is Vivian, and my group members are Javier, Micah, Ryan, and Dalton. And our project is about Universe Glide. Mutual induction is the interaction of a coil's magnetic field and another coil's magnetic field, in which turns induces a voltage in the later coil. Farader's law of induction. Farader's law of induction is the concept of how magnetic field interacts with an electric current in the order to produce an electromotive force, a process also known as electromagnetic induction.
So for this experiment, we decided to focus on the concept of Faraday's law of induction by creating a mutual inductance system. The way we integrated Faraday's law of induction was by observing the electromotive force created when the number of copper coil rings is changed. So before starting off our experiment, some of the materials we will need to showcase the concept of Faraday's law of induction include copper wiring, an ammeter, plastic hollow cylinders, and a graphing program. Next up, Ryan will introduce the formulas needed for our experiment.
So we need to know Faraday's law, which is negative number of loops times the magnetic flux over the change in time. And we also need to know what mutual inductance is, which is the electromotive force produced in a coil due to a change in current in a coupled coil, which is mu naught, or the constant of permeability of free space, times the number of loops in coil 1 times the number of loops in coil 2 times the area of the coil all over the length of coils. And then we will use that to find the EMF of the second coil, which is negative m times current 1 times 2 pi times the frequency. And then we'll go to the results.
So what we found was that m times 2 pi f is equal to the electromotive force in the second coil, which is induced by the current in the first coil. Because of how the nature of our experiment, the only thing that is changing is the number of loops in the first coil, as well as the frequency that the current is being pushed through the first coil. So doing this, we can get values which are a little difficult to explain, but basically are showing the EMF in the second coil as it's induced by the current in the first coil, or in the second coil, I should say. And so doing this, you can see theoretically, we got numbers for 10 hertz, 100 hertz, and 1,000 hertz, as well as experimentally for the same thing, getting relatively close values. So what this means is that we can see there is a correlation between number of loops and the frequency that the current is put through the first coil. This is an example of what one of the sine waves looks like for the current and the voltage while the experiment was running. So one of the sine waves is proportional to the output current, and then one of the sine waves is proportional to the voltage that was read in the second coil.
So in conclusion, by using the data provided through the ammeter and the graphing program, we were able to find out the amount of coil rings affected by the electromotive force produced by changing the frequency of current passing through the mutual induction system. Through Faraday's law of induction, we can calculate that the number of loops N is directly proportional to the amount of induced electromotive force in the apparatus.